Excited to have everyone here. Hope everyone enjoyed the keynote. It was really exciting to see where everything's going. But we're going to take a swift pivot to web, the weird and wonderful world of everything web game development in the Unity ecosystem. So I'm Josh. I am the founder of Stratton Studios. I have been playing in the web space for the last number of years, doing things that I probably, shouldn't, but, here we are today. So, agenda. I want to talk through today how we think of web, how we set up projects, best practices we've seen, and how we've adopted WebGPU at Stratton. We've a number of products in market, which I'll talk about later, but, per month we get millions of plays, and we've learned a lot on that journey to get there. So let's start off with how we think of web at Stratton, because we've kind of built our own playbook for doing it. Firstly, though, I want to talk about why we choose web. Web was something that came on my radar a couple of years back, and it kind of instantly caught me. The allure of instant access and rapid iteration excited me. Coming from traditional AAA game development, where everything was very slow, took years, it was a refreshing break to be able to just get content in the hands of users very swiftly without having these massive binaries or big barriers to entry. It also allowed us to tap new markets that just hadn't been tapped before, and allowed us to access more players, which was very interesting. And as part of this, we had to learn to embrace different things. Load times became our new bastion that we had to embrace, and we had to quickly learn how to change how we made games to work within the web ecosystem. And that loads into our biggest challenge, the loading screen. Web games inherently brings the kind of appeal of instant access. People want to play now, not in 5 seconds time. Each millisecond that you lose to a loading screen is a churned user that does not play our game and does not come back. And, especially when it comes to the mobile market, people are very sensitive to delays. People, especially on web, are moving to this bite-sized, digestible content pieces where they want to just keep churning. They want to play now, not later. So the biggest challenge that we have has been trying to overcome the loading screen. And we've worked tirelessly to essentially be able to get over that, essentially. And to do this, we've built a playbook. This playbook has been battle tested. We've learned through blood, so to speak, a lot of mistakes, a lot of failures, but we've been able to, build a framework that enabled us to have repeated success when it comes to any of our web games. So essentially, I'll run through a few things real quickly. We use addressables for everything. We need to offload content as much as possible. We want to keep our game binaries maximum 30 megabytes and below. That is like table stakes. We go over that, you see too high churn and players just ain't going to play. And it also cuts out a lot of your market as well. We also like the addressable system because it allows us to rapidly update all our content. We need to be able to change things on the fly as our users are responding to it. And the great thing about web, and also the bad thing about web, is that you can make mistakes easy, but you can fix them easy also because there's, you control your distribution. We host everything on global CDNs to make sure things load fast. Which is awesome. We use Cloudflare, which was a bane the last few days because Cloudflare had an outage. We compress everything as well. There's plenty of compression algorithms out there. Unity native supports Brotli and gzip, which are awesome and allow you to just bat down that binary even more. Quick test: if you ever build a web game in Unity, try an uncompressed build and then try Brotli. You'll be very surprised. And we also want to streamline how we're starting our games. There is no need for us to load stuff from level 5 at the start as the user's getting into the game. It doesn't make sense. So you just need to get smart and intelligent about how you think about getting players into your game so they can get in there the fastest. And that kind of lends into how we set up our projects for success, because it's essentially we built pretty much a template. And to do that, the first decision we got to make is WebGL versus WebGPU. For anyone that doesn't know in the room, just to set context, there are different graphics APIs. WebGL is an older graphics API that's been around for a long time. WebGPU is a newer graphics API that allows you to do cooler things, which we'll talk about later, but just to set the context. WebGL essentially enables us to access wide variety of devices. It's supported pretty much everywhere, and it allows us to reach a large audience, essentially. It doesn't have as complex graphical features as WebGPU, so it's great if we're targeting, say, casual mobile games or lightweight experiences that don't tend themselves to have heavy 3D applications or whatever it may be. Then we move to WebGPU. WebGPU is like the heavy hitter or the juggernaut in the room. This is what we use when we're trying to make a first-person shooter in the browser. When we want to do big 3D worlds with, VFX graph, compute shaders, all of those cool things that we're used to when developing, say, a console game, you can now do it in web using WebGPU. The only caveat to WebGPU is you're looking at a smaller number of devices. Device support is gaining day by day. I will say that. A year ago when I talked about WebGPU, it was in preview a lot of places. Now it's actually, the support's getting pretty good, which is awesome. But we make this decision and we kind of fork off from there when we start to set up the projects that we're working on. And this kind of tends into what I was talking about, maximum reach, lower barrier to entry, and there's a proven ecosystem of WebGL games out there. Most games, if you've ever played a Unity game on web, it is probably using WebGL. It is using WebGL. So it's got years of kind of battle-hardened kind of success in market, and there's a very proven path there. And that's when we jump over to WebGPU, which is very new. When we launched one of our first games, Project Prismatic, using WebGPU, we were one of the first that did it. And when you do that, there's a lot of things you got to learn. So it's a very uncharted territory, but that territory comes with a lot of treasures and a lot of gains. You can make things look amazing using WebGPU, especially in Unity 6. Stuff like VFX graph, compute shaders enable you to create really full immersive worlds that just haven't been seen before, typically in web games, and kind of allows you to break the barriers down there. So if we're trying to do something like that, WebGPU is the option that we choose every time. There is shared scaling challenges across these games. As I talked about earlier, you need to compress everything. You need to get super, super opinionated about how you compress things. You need to be stringent. So much so that we started, and we discuss it later, but we started to change our asset pipeline in Unity to be able to get further reductions on our assets that we're using in-game. Your draw calls and on-screen topology, you need to optimize it as much as you can. Traditional processes that you would use as normally part of game optimization, LODs, billboards, map paintings, all of that stuff, you need to employ that. You're not going to get away with just throwing big meshes on screen. It's going to kill your performance every single time. And you need to strip everything that does not need to be there, and get really, really creative about how you do that. So much so, in some of the games, we were cutting rocks in half and rotating them around. So you got to do a lot there. And then memory management. Memory is also kind of a bane in web. It's gotten better with time. We've had increases in the amount of browser support, but still, it's not, you can't throw 16 gigabytes of memory at runtime. It just won't work. Maximum that we push is a couple gigabytes. That's it. And that even then, you're going to start to cut out device support, which you don't want to do, because the allure of web is instant access and wide device support. So having talked about all this, we then start to move into how we set our project's technical budgets, essentially. So first things first, we decide what game we're trying to make, what are the benchmarks, what device and what market are we trying to hit. If we're trying to target devices in Southeast Asia, we're going to have to set a lower kind of more stringent technical budget. And then once we've done that, we kind of backfill it into whether we're going to use WebGL versus WebGPU. We come to a conclusion and then we stick to that. But we have a very stringent framework, so much so on our Jira boards, and asset approvals, we have poly counts. If you go over those poly counts, it ain't getting in the game. It's not happening. Same with texture sizes. We got to be super, super picky. There's a couple settings. I would recommend taking an image if you want. These are great settings that will help you to set your project up for general success in web in Unity. So reduce shadow cascades. This is a big one. A lot of Unity projects are used to having like 4 or 5 level shadow cascades. You don't need it. 1 or 2 is fine if you're going to do real-time shadows. It helps a lot reduce the GPU overhead, especially in certain browsers. And 4+ rendering, this will save you a lot. Last year, it wasn't as advanced, but this has really enabled us to push some serious on-screen topology without the typical per object light limit that Unity has. For anyone that doesn't know what Forward Plus is, it's an evolution of the Forward render pipeline, and it essentially lifts that object light limit in Unity so you can have more lights affecting things and making it look better. It's really good, especially if you're doing kind of indoor scenes or whatever it is where there's a lot of dynamic lighting coming in. And then you just need to be pretty sharp about what post-processing effects you're using. Are you using ambient occlusion? How is that being implemented? What type of aliasing are you using? All of that jazz you just need to get pretty stringent on. Cut everything you don't need. If it only improves your game's visual fidelity by 1 or 2%, guess what? It needs to go, because it's just going to hurt runtime performance. And this kind of comes into the assets and how we think about game assets. I talked a little bit about this earlier, how we changed our asset import pipeline. We do not use FVXs or OBJs when it comes to any of the web games that we make. We use Draco Mesh Compression. Draco Mesh Compression it was made by Google. Essentially, it's open source. Everyone can go use it. But we built a pipeline that we can import the meshes into Unity and use them. Why we do that? Essentially, it's lower file sizes. We've seen anywhere from 30-40% reduction on base FBXs, which is awesome. If you've got a game full of meshes, that will help a lot. Next one. This is the big one. Textures are your enemy when it comes to web. They'll get you every single time. Images are just so bloated, it's just a nightmare. So that's why we had to rip out the traditional, PNG, JPEG, TGA pipeline, and we had to use KTX2. Or Basis Universal Textures. They're essentially, GPU-ready textures. The cool bit about them is file sizes, again, wax it right down, and they also perform much better as well. There's native packages out there, open source, that you can push that in to Unity as well, which is awesome. But that's a new pipeline that we had to use. So, we had to slightly modify the way we would typically import assets into Unity. The next one is audio. We use Opus audio compression. Again, just extra file savings, really trying to drop that load time and, optimize from there. So this was like a whole kind of evolution that we went on as we were making these games, and we just kept hitting those memory limits, and we just had to optimize further. So that's how we think of assets. And then as we move to essentially programming architecture, because we think of this as, multi-phase kind of development approach, you need to break everything into small systems. Your monoliths need to go. It's just not going to fly. You aren't going to get away with a lot of the stuff you will maybe on PC console, where you have just a little bit more legroom. You need to essentially, if it doesn't need to be on screen, doesn't need to be running at that point in time, get rid of it. Cull it. There's plenty of APIs out there to do it. And you also need to embrace kind of an async or await pipeline. You're going to have to get very good at streaming assets. If you haven't done it before, you're going to have to, learn it. Because loading things in and out, especially as you transition from level to level, is just something that's table stakes that you're just going to have to get good at. This will also help prevent any, frame hitches or any of those things that generally you would see if you just try to pack it all in and just hope for the best. It doesn't work. And also, you need to be kind of, I call it platform aware. Some games that we've made need to support WebGL and WebGPU for furthest device reach. So we want those high level graphics. We want, people who are on the gaming PCs to have the highest fidelity, but also we want to support that player in Southeast Asia who's on a mobile device that's $50. We want that too. So you need to get very good at being, agnostic with being able to, kind of scale things up and down as needed. And this doesn't just suit for web. This is just general best Unity practices. Just be smart about how you're doing things, and follow, all the recommended guidelines. Hosting. This is one that can make or break your web game. And I will say this, when we launched Project Prismatic, which we'll talk a little bit about later, the first month we seen, I think it was nearly a couple terabytes of bandwidth usage. If anyone's ever done any sort of stuff on like the likes of AWS and you're paying for ingress and egress, that gets expensive quick. Especially if your game isn't, it's a free web game, that can really hurt you if you're not careful. So you need to get very aware about the cost of delivering this content to your users and how you do it intelligently. As I mentioned, we use Cloudflare, which is generally pretty stable. And famous last words. But just find a provider that you trust, that you're used to using, and host it there. I wouldn't recommend building this infrastructure yourself. We tried, we failed, we quickly learned. We'll just call Cloudflare. But it remains good. You need to use something that's scalable, that has CDNs around the world. Again, this can actually impact your load times quite aggressively as well. If you're not using something that's actually well distributed, you're just going to have problems. One of the initial learnings we had was that Project Prismatic was performing terribly in Australia. And we couldn't figure out why. And then it turned out it was because the host we were using didn't have very good infrastructure there. So this can impact you. It'll increase your load times if you're not careful. And then obviously you want the minimal amount of downtime as possible. But I'm going to glance over that one because of the last couple of days. This is new stuff coming soon. This is exciting. So in 6.4, it's slated to release that there's going to be PSO tracing and pre-cooking. For anyone that doesn't know this, here's a quick experiment that you can run when you get back to your computer. Spin up a 3D game, Unity in the web, and put a crap ton of meshes on screen with loads of different shaders. And then I want you to spin around, and you're going to notice frame hitches consistently. What's happening is shaders are getting compiled at runtime as they're coming on screen, and it's causing these nasty frame spikes. This will prevent that, essentially. This was probably one of the things that made Project Prismatic a success and actually able to run. So this is coming soon. It's exciting, especially if you're working on any 3D games. This is going to help you a lot. It just enables those to be pre-cooked so they don't have to be done at runtime, which just makes everything faster, better, and more accessible for everyone. So this is a really good one. It's more of a kind of behind the scenes thing, but when it works, it's great and you don't have to worry about it. When it doesn't work and you got to deal with it, trust me, it's a nightmare. Then I'm going to move into kind of done a lot of talking about stuff. Oh yeah, we've made these games, we've done all this. But we've done this put it to practice, and we're actively in market trying to push best-in-class web games out there. Screenshot on the right is running in Chrome, and that's a game called Project Prismatic. It's available, everyone can go play it, it's free. And essentially, this was a culmination of all of the various different techniques that we talked. It is a first-person shooter, very similar to the likes of any sort of, sci-fi shooter you've played. It's got dinosaurs, it's got aliens, it's got explosions. It's a fun time, especially running in a browser with a 72 megabyte binary right now. And with that game, we broke the rule. We generally said 30 megabytes, but this one's a big one. It's only for desktop, and it's built just to push the boundaries of what you can achieve in web. It's got everything from a full open world to all that stuff. So that one has been the culmination of all of these techniques together to really push the boundaries of what we've done on the website. And as we do that, now I want to talk a little bit about the games we've actually shipped. Because I think, talking about stuff is nice, but the practicality of showing stuff in market, running in browser is important. So I'm going to show a quick video of a game called Ashline Racing Born to Burn. And that is our take on a traditional racing game for web. So this runs on, and it's in market, it's launched, our bigger player space is actually in Asia. So I'll show you guys it and I'll talk a little bit more about it. And so essentially there's no sounds. Yeah, we'll hear a little bit of it. But essentially you can see we've got full 3D environment. This is all running in Chrome and multiple kind of cars driving around. You've got these vast kind of 3D environments performing decently well. This is on mid-level hardware as well. So it's interesting. Not typically what you would associate with a web game, especially considering players can play together and there's, 10 plus tracks in game that players are playing across. This has been an interesting one and has been very high performing for us, and we've been pretty excited about it. And this is only one of the games in our portfolio. Here's some data on that we've kind of collated of our web games that have been in market and that have done decently well. So we've over 50 million players right now across our web game stack. That's growing month on month. We get a couple million players a month. We have 8 different titles across a variety of genres, everything from casual first-person shooter to racing games, and we've also got some puzzle games as well, and collating to a total of 4.75 years of gameplay. So the whole point is that we're doing a lot of this, and we're kind of actively pushing this in market, and we're trying to dog food our own tech and really push the boundaries of what can be done in web and actually make it scalable, which is important. To talk a little bit about our hosting pipeline as well, because I think this is interesting. We have this interesting pipeline where we can go from our dev builds to in-market with users within a couple minutes. I think our normal run turnaround is about 8 or 9 minutes. We can go from in-editor to a push build in cloud. Essentially, we have everything hooked up to GitHub Actions, which runs builds, and then it gets pushed into our CDN. We then flush the CDN, and then within minutes, users can get the new latest and greatest build that we have. This paired with the WebGL and WebGPU runtime makes things really efficient to iterate on. And players love it because we are able to make changes quicker than most they've ever seen before. Like traditional mobile games, they're used, or Steam, they're used to having to package in a binary. The release will be out next week. We have players reporting bugs and they're being fixed within 30 minutes. And it's like, oh, this is interesting. This is powerful. It also allows dynamic content to get streamed in, and we can be a lot more brave with the features we ship as well. If something doesn't work, guess what? We just revert it. It's just a HTML file. So it's very easy on that front. And we found players really enjoy this level of access to what we've been doing. And then this comes into how we release updates. And this is an important one. And this is one I think people should take note of. It is not wise to just ship everything at once. And we learned that the hard way. So the way we do things is we have a couple stages to our pipeline. We do a 5% rollout to users when we get a new build. This is a small segment of our most active players. We use them as our QA testers and we see what the response is, watch our retention numbers, see if any error rates are going up. If it looks generally good, then we move to stage 2, which is a progressive rollout, which we can do through our CDNs. We can dynamically set how the content's rolled out. If no P1 bugs are found, and then we roll it out until it hits 100% rollout. And then we have a mechanism, if error rates go too high, we automatically roll back to the previous build that was most stable. So we're really trying to optimize and not lose or churn users, because that's not what we want to do. You'll see on the right as well some more screenshots from some of the games that we've made, everything from football games to casual to shooters and racing games. One thing, and this isn't something that most people talk about a lot. Games is a business, as you know, that's an important piece. And so acquiring users is one of the most challenging pieces most people struggle with today. This is one of the areas that interested us very much so when it came to the web runtime. And we've had great success with doing it. So what we did was we done a strawman campaign to see how much we could spend to acquire users on web and how successful it was being. It was astonishing. Anyone here in the mobile free-to-play market will know CPIs can range anywhere from, $5 to $20, depending on the genre you're in. We didn't see that at all. With a budget of only like around 5,000 US dollars, we were able to generate over 10 million impressions, 2,000 views, and 1.1 million plays across our games. Pretty astonishing numbers to be able to acquire users. The view to visit conversion rate was nearly 57% as well. So these numbers are going to change wildly depending on the game you'd made. The game we were promoting in this was a first-person shooter. It's a very desirable genre, especially when you give the allure of click the content in a few minutes. But the resounding point is we aren't paying $5 to get someone to play our game. We're paying fractions of a cent. And this has enabled us to scale up to having a user base of millions and millions of players, where there are players, we control, how we communicate with them, which is super powerful. It enables us to just get closer to the player, and the closer we are to the player, the more we can, build stuff that they actually like. And this kind of goes into the next piece of being a business in web, which is how are we monetizing? Because you want to make great games. You can't just not make any money forever. I mean, you could, but it just wouldn't work out too well. So we're trying everything to make web work. And we've had some success. We've had a lot of failure. But these are the elements that we're trying, so we'll run through them. So we're trying with our Project Prismatic, we're trying episodic premium releases. $5 to $10 an episode, you get 20 minutes of gameplay, traditional, content pipeline, user pays for an episode to get an episode. This has been interesting. A small set of users love this. A large set of users don't. So this it's been okay, but I wouldn't say it's something we are actively trying to build a business off, and we are doing it because we believe that we want to show that we are the best at making best-in-class web games, from a graphical perspective. So that's why we are continuing to push down that route, and we'll continue to see. We think it's going to take time for the market to move. Next one's in-app purchases. Traditional, mobile in-app purchases. This works. There's a reason it works. Players like buying things, I guess. And it's driving strong monetization across some of our more casual games. So bubble shooters, solitaire, all those games, people buying skins, all that jazz. People like it, enjoy it. It drives good monetization as well. Then the last one, which is interesting, is what we're referring to as GaaS, which is Games as a Service. This has been probably our most successful way of monetizing. And this is what has enabled us to fuel all of our other games that we're making right now. And what do I mean by GaaS? So essentially, we do a deal with various different platforms. We don't charge end users. The platform pays us for the content. Similar to an Apple Arcade model, pretty traditional. And this has been hyper successful for us. And we've been able to make some really, really cool games and still run the business quite efficiently also. So this enables us to do everything, and we just think of the game as like a live service platform. So we're shipping content consistently, we're running the full live ops pipeline with it, and we're retaining players, retargeting them through content drops, competitive, features, all that jazz. And we're, continually optimizing for retention. So very traditional, like, free to play mobile, except we're not trying to monetize the user. We're just getting paid off a platform. And there's one here that isn't, that was like an evolution since this deck was made, which is we've dived into traditional in-game ads as well. That is proving very, very lucrative also. And especially in the Chinese markets and Russian markets, we've launched a whole host of games and they're doing very well. So that's another one that isn't here, but is quite lucrative if you kind of architect it correctly. And I just want to hold on this for a second, because the allure of making great games is to make great entertainment pieces for users. It's not to just turn your users into a cash cow that you just try and get as much money out of. So ethically monetizing is something that is going to be new for web, because it's just, there's no proven path right now. So you got to try a lot of things, but it's all rooted in what's best for the players and what's actually going to resonate with the players also. So that's just always something I like to highlight. Let's talk impact. So these are some of our games, a whole host of them. We'll talk a little bit about them. Prismatic, we've talked about, first-person shooter, Unity 6, WebGPU. It's had about 4 million players to date, and that's growing month on month. The initial episode's free to play, and then we're charging post that. Ashline Racing, Born to Burn, 1.4 million players to date. That is doing well. It is, still in like what we're considering our soft launch phase. And we're, going to keep iterating on it. And then there's Icy Scream Haunted Bubbles. That is, if anyone's from the US here and has ever gone to 7-Eleven, you'll probably see those Slurpee things. That's them in all their glory. That's been very well. That's a traditional bubble shooter style game. We launched that in collaboration with Icy across stores in the US. And yeah, it's done very well. Continues to do very well. Retains people crazy. Funny enough about Icy, that actually retains our highest playtime among all our games. Average playtime on Icy per day is 36 minutes, which is wild. People like bubbles. So future stuff. And this is like, and I put this slide because things are changing. I did a talk at Unite last year about web, and the conversations that we're having today are so different to the ones that we had last year, which is awesome. Unity WebGPU, this is the future. WebGL is a standard that is going to stay, but over time it will become obsolete. The reason being is WebGPU is powering creators to do more. Better performance, bigger experiences, allowing creators to be bolder. So over time, WebGL is going to become just a legacy, technology. I don't think it'll go full flash, but who knows? But this is exciting. And, Unity's been at the forefront of pushing the WebGPU standard forward, especially when it comes to the web runtime. And so that's super exciting. It's in Unity 6. You can try it, play with it. And oftentimes, if you have a game currently that's out there and you just port it off to web and the WebGPU, it might work. Give it a go. The new graphic state collection system, this is more of a technical tourney one, but this is important. Ultimately, the success of web games is going to be derived upon how well they perform on device. If there is no discernible difference between a game on a console and in web, then web will win, because guess what? It's easier to access. And people want to get into things faster. They don't want to wait and have to be gated. People want to play where they want to play. They don't want you telling them where they want to do it. So this is an important one. The more we can optimize how we're managing GPU state or, shader compilation, all those good things is going to make it better for everybody. And this is more of a standard thing across the board. The other one that I'm super excited about is burst support for the web whenever that comes. This is like The more we can, make things, I'm not even going to try to say the word, but we can do things at the same time is better. One of the challenges with web that we constantly struggle against is we're hitting, whether it be GPU or CPU overhead, we're trying to do crazy things and we're just hitting a brick wall. The more we can split those across web worker threads or whatever it may be and really take full advantage of, WebAssembly is going to just make all of that better. And these are things that are evolving over time. These are things that we weren't even talking about last year. And now we've solved the things that were, were problems last year. And this also moves into Forward Plus. Stuff like Forward Plus is changing the landscape of how much you can do in web. Per object light limits for anyone that's developed with Unity for a long time, especially if you're trying to build a performant game, is an absolute nightmare to manage. It's like, which light's more important? They're all important, so you don't really, it was always a challenge to get that to work well. This just makes that much more efficient. And it has really allowed us to optimize our games further and just do things that we couldn't do. I'm a big believer. Oh, this is one actually caveat to that that's important. Baked lighting in web. Don't try it. It's just you're going to have a nightmare because you've got all those baked light maps. Good luck compressing those into the build. It's just challenging. You can do it, but also depends on your game. And I say that and I be verbose about it, but it's challenging. The more textures you have in the build, the harder time you're going to have. So we're a big believer in real-time illumination in the web builds. At least that's the way we've been able to do it. In Project Prismatic, we tried to bake our textures. We tried to do all that. We tried to compress them right down to 256 by 256. We tried everything. And our build size ballooned up to a couple 100 megabytes. We quickly realized this was not the path for us in that game. Maybe there's another way to do it, but that's at least our experience with it. So this enabling us to just have more real-time illumination, real-time shadows, it just makes everything feel, more efficient, more tighter, and closer to that experience and that allure that we've been talking about for the last while. And that kind of brings us close to, kind of the content that I wanted to talk about. I wanted to leave some time at the end for us to ask any questions because there's a lot of stuff around web that maybe, people have questions on. So yeah, that's the talk. So any questions?